Now, for the first part, given this equation right here, we need to simplify it and express it only with positive exponents. And so if we got negative exponents, we got to convert them to positive exponents. Now, right off the bat, the first thing that I can see here is that we can expand the inner exponents right here. And so the 4 goes on the 2 and the x, and the 2 goes on the 12 and the y cubed. And so we need to expand all inner exponents. And so if we do that, we get 64, and so we get this one right here, this equation right here, or this expression right here. Then we can actually do 64 times 4, and in the denominator 16 times 144, and so we get 256, and then 2304, and the same stuff in this equation, in this expression right there. Then we can take the square root. So square root of 256 is 16. Square root of 2304 is 48. And so we take the square root, which is the same thing as to the power 1/2. And then right here we can say 16 over 18 is the same thing as 1 over 3. X to the power 18 over x to the power 4 is x to the power 18 minus 4, which would be x to the power 14. And then we have y to the power negative 8 over y to the power 6, which equals to y to the power negative 8 minus 6, which equals to y to the power negative 14, which also equals to 1 over y to the power 14. And so y to the power 14 goes right there. And so our final answer would be x to the power 14 over 3y to the power 14. Now, for part 2, we're given this situation where there's this painting that was purchased or bought in 1980 for $995. Its value increases 3.1% yearly, and we need to create a function to model this growth or this situation. And so, first off, we need to get two variables straight. First off is y, where y represents the year of interest minus 1980. So let's say we're talking about the year 2003, then it would be y would equal to 2003 minus 1980, which would be 23 years. And so y would represent the number of years that have passed from the initial year, which was 1980. And we need to say let v of y, which is a function, represent the value of the painting at the year of interest minus 1980, which is once again 23, let's say, if it was 2003. And so the function would essentially be v of y, or v at y, is equal to our initial value, which is $995, times, and it increases 3.1% yearly. And so if it increases, then it's 1 plus 0.031, because it's 3.1%, which would be 0.031. And so it's 1 plus 0.031, which would be 1.031 to the power of y, because it increases yearly. And so that would be our final answer. Now, for this part 3, given the base graph g of x equals to 2 to the power x, we need to get to the graph g of x equals to 2 to the power negative x minus 3 minus 4. And so the base graph right here, which is this blue graph, base graph, to get to the green graph right here, we can clearly see a horizontal reflection over the y-axis. Then from the green graph to the yellow graph, we can clearly see that it's translated left by 3 units. So it's a horizontal translation. And then we go 4 units downward from the yellow to the red graph, indicating a vertical translation down 4 units. Now, the y-intercept can be calculated in 2 ways. Number 1, algebraically, and number 2, graphically. And so the first way, algebraically, is where you can substitute x equals to 0 into this equation right here and calculate g of x. And so if we substitute, we can say 0 plus 3 is 3, and so it becomes negative 3. 2 to the power negative 3 is 1 over 2 to the power 3, which is 1 over 8, which is 0.125. And 0.125 minus 4 is negative 3.875. So it would be 0 and negative 3.875. And in fact, we can confirm this. This is close to 4, approximately there. So it is about negative 4. And so it is about negative 3.875. The asymptote in this case would be a place where it infinitely approaches, but it never hits it. And so it would be y equals to negative 4 right here. It infinitely gets there, but it never all completely gets there. And so y equals to negative 4. The domain is going to hit, this red graph is going to hit all x values. And so the domain would be x is an element of all real numbers. The range, however, in this case, will be, it'll go from y equals to negative 4, this graph, or, well, not totally there, but it'll always go from always infinitely closer to y equals to negative 4, never hitting there, all the way up, infinitely upwards as well. And so it'll be y is an element of all real numbers such that y is always greater than negative 4. For part 4 right here, given this purple graph that's shown, and the base graph, which is 1/2 to the f of x equals to 1/2 to the power x, we need to figure out a way to get from the base graph to the purple graph. And so the first thing that I thought of was to graph the base graph, f of x equals to 1/2 to the power x, and that's this blue graph right here. Now, I also thought right after that this is probably, the purple graph is somewhat, like, not somewhat, it's if you vertically reflect it, you'll get closer to the purple graph. And so I thought of doing f of x equals to negative 1/2 to the power x, and that got me to the red graph right here. And then I noticed that as soon as you move this guy up all the way to here, or in other words, up 4 units, then you can actually get to the final graph. And so we can say f of x equals to negative 1/2 to the power x plus 4, and this would definitely be our final graph. Now, for the last part, part 5 right here, given this equation right here, we need to solve for x. And so the first thing that I notice as soon as I start off is that all of the numbers 2, 64, and 128, all of the bases, are all powers of 2. And so we can all, or 1 over 64, and so 64 is a power of 2 as well. And so we can basically express all of them as powers of 2. And so 64 is 2 to the power 6, and 128 is 2 to the power 7. And so we can say write all bases as powers of 2. Then I notice that 1 over 2 to the power 6 is the same thing as 2 to the power negative 6. And 2 to the power 7 all to the power 2x minus 3 is 2 to the power 7 times 2x minus 3. And so if we do that, we get right here, 2x times 2 to the power negative 6 equals to 14x minus 2 to the power 14x minus 21. And so pretty much what we did is just simplify there. Now, using the exponent law, where if you have the same base, you can add the exponents. 2 to the power x times 2 to the power negative 6 would be 2 to the power x minus 6. And so you can simply add the exponents right there. Add exponents. And then we can use the special method equating the exponents, where we basically say that since the bases are the same, and this is an equation, the exponents also equal to each other. And so x minus 6 equals to 14x minus 21. And so we can just solve for x by bringing the x terms on one side and the other terms on the other. And so here, our final answer would be equal to 15 over 13. And that would be our grand final.